Hello, I'm Guillermo Castilla and this is AULA UE. Today we're going to be talking about the geometric model in discrete distributions, discrete models. The geometric model is vaguely similar to other models. It's actually a simplification of a few of them, and it only depends on a single variable p, which is the probability of change. In exchange, q is the complementary of p, and it would be the probability of 1 minus p. So it's the probability of not changing. Now, imagine we have a production line. Yeah, this one's okay, and this last teddy bear over here is not okay. It's a reject. We have to reject it from the line. So we'd have a fourth reject in a certain line. Well, first of all, we'd have to know what the probability of rejection in the line was. Well, there's a 5% probability of one of these teddy bears to not work, to not be commercial. So our random variable chi, in this case, will go from 1, which is the first reject we can find, to infinity, which would be the last place where we could find a reject. What the model itself does, what it really does, is establish what the probability of having a certain event that happens time and time again. We know what the probability of changing that event is. In this case it would be a 5%, and what it gives us is the probability of that change taking place after inspecting x elements. In this case, for example, as you can see there's the quantity function p. The probability of chi being x would be f of x, would be q to the power of x minus 1 times p. So in this case, the probability of chi being 4, for example, finding the fourth element as the reject, would be f of 4, which would be q to the power of 3 times p. In this case, q is the complementary of p, which is p is 0.05, sorry. So q would be 0.95. So it's 0.95 cubed times 0.05. So the probability of changing is that 5%, and the probability of that change taking place after 4 inspections is that 0.95 cubed times 0.05. So the important parts are p and q, okay, and to know when it happens, okay. In this case, I can really say it. We have a problem where there's only 2 possible outcomes, okay. Either the thing changes or it doesn't change, okay. And through that pair, that only possible pair of events through p and q, what the model gives me is the probability of the change taking place after x inspections. So what I really want to know is what the probability of it happening is and when it happens, okay. So it can happen the very first inspection. That's why chi goes from 1 to infinity, because it can start. It can happen in the very first element I inspect, or it can never happen. It can happen in the infinite element. So this is just a process that goes on and on and on and on till I find the element that changes. Evidently, these probabilities can be calculated through a distribution function like this capital F I'm writing here, which is the probability of chi being smaller or equal than x. Again, it's the summatorium from k equals 1 to x of q to the power of k minus 1 times p. Well, I hope you enjoyed this, and I will see you very soon.